So, hello. So I'm from the mobile phone tribe. As we heard today, we are sort of sorted into tribes. I'm from the mobile phone industry, and I give you today here a brief introduction how things are actually happening behind basically the antenna and what's going on there. We have here a joint work between me and Flavia. Flavia is now with Elisa. So I will introduce you to industrial research and to honeypots there. We start with honeypotting, let's call it that way. So let's start with a brief, what's industrial research? I'm not sure sort of how many people are here familiar with industrial research. Everybody knows university research and papers and so on, but I'm from industrial research. Things are a bit different there. They are good and bad. So the good things are I get to see the real stuff. I really get from customers the attacks. I see really data. I can talk to people that really affect your life, meaning really the operators where you connect right now to. I talk to those people, they talk to me, we share data and so on. But on the other hand, it also means I sometimes have to keep my mouth shut in the sense that cannot divulge sort of who has problems and who doesn't have problems. And it also means that when I find something, I cannot just say, here's a big problem, the industry has to fix it, because I'm part of the industry. They come back to me and say, fix it. So, but on the other hand, I know, for example, I'm now 18 years in industry, and I know that everybody here in the room has something that I have designed with regard to security. So the work I do in industrial research, it really touches everybody basically on the planet that uses 4G. So there are pros and cons to the industrial research. So if you ask later on about specific operators and so on, I cannot answer you that, but I can give you a general picture about regions, let's call it that way. So in short, I cannot troll around like some academic guys and say, oh, they have to fix it, because we also need working answers. The stuff and the solutions, you might say, why are you not doing, let's say, IPsec or something? And I would say, hey, we would need to switch off roaming for a year. So that's not a feasible solution. And so we have to have working answers in telco industry. So I cannot just troll around. I would start with you something sort of called brief history of roaming and why there is no security or very little security, or why the security looks like it looks today. So we are here in Finland. We have a subscription from DNA or Elisa or Telia, and the participants here are all from over the world. They have China mobile subscription, or Airtel if they are from India, Megaphone if they are from Russia maybe, or Telenor if they're from Norway or from Kazakhstan or similar. So these guys come here, they switch on their phone and it works. And this is somehow a little miracle, even if you don't really recognize it, because these are different operators. They are different legal entities, and they don't have a sort of overall entity that rules them and say you have to do this or you have to do that. Still the connection and so on works. And there is no central entity ruling those guys. And they work in very, very different political environments. Their network connect like Pakistan and India, they're connected. China is in, US is in, North Korea is even in. So there are a lot of participants in there that don't necessarily like each other, and some of them are misusing this network also. So let's assume now I'm a visitor from Elbonia. I have a marvelous paper phone, and I connect now to some antenna outside because I just arrived here and I want to connect. So I connect to an antenna. Let's say I saw here some on the roof of the Kapellitehdas. And then it goes to some Finnish core network. The core network, the Finnish provider doesn't have a direct cable to Elbonia, so it goes via some sort of carrier in between. And this carrier then connects to Albonia, and here we have the marvelous flag of Albonia. I found it from a very reliable source, from Reddit. So, and then it's checked if this is a real subscriber, if it's prepaid, if it's postpaid, or so on. The authentication is done, and after that, I'm from Albonia, can use then this service. That's how it's supposed to run. So, to understand the security of this, we need to see where this is actually coming from. So, and this is going, so the messages that I just talked, they go through the IPX network. The IPX network, it's something like the internet. It's a private network, it's a closed network, and we'll go to the private and closed later on. And it's used for operators to connect to each other and send the data to each other. So everybody here in this room is actually connected to this IPX network via the local provider you are connecting to, so that somebody from abroad can call you. So this is the IPX network, and we will show how it evolved and where are the problems with this. So let's go back to history. I assume this is the Nordic operator meeting in '81. I'm still hoping for somebody here in the room who can confirm that it really was like that, but I would assume strongly it was like that. So those guys at that point of time, they had real problems. They didn't have Facebook, they didn't have Instagram, they didn't have Twitter, so they had real problems. And so one of their problems was that, well, social communication, so they needed to call the wives, gratulating for the birthday, the sauna was cold, the beer was warm, so they really had very serious problems. And so they were thinking, yeah, let's connect the networks to each other so that we can have in the Nordic networks a common infrastructure so that I can call you to switch on the sauna in time and put the beer into the fridge. So they went down to the technical details, how to do this actually. So basically they were discussing, okay, the networks at that '81, they were government owned. These guys were more or less the same cultural background, so they had the same understanding how to do things, how to run security, how to run networks, and so on. So the networks were owned by governments mostly at that point of time, and they just plugged them together. They were saying, why should we bother with security? It's our networks, and you know I trust you and you trust me, and that's all fine. So, and then they designed some protocols how to do this. It's a bit like the start of the ARPANET. If you remember that, how has that evolved, it's very similar. So they actually designed then the interconnection network, or the first version of the interconnection network. And so Finland, Sweden, Denmark, and Norway, they connected their networks to each other. They were very similar with, so same structure, same type. And it was a huge success. I mean, everybody knows that nowadays you can roam everywhere, you can travel to the farthest islands, still have connectivity. And actually nowadays you also have things like that you get your SMS appointments from your dentist so that you don't forget it, and things like that. So there are nowadays a lot of one-time password resets. How many people here have seen this SMS password things? So there are a lot of service providers also nowadays using this IPX network or these APIs to operators for their services. So these little plants there, which are sort of somewhat similar looking, then evolved and grown into a huge interconnection structure. So instead of these 4 operators started with, we have something now like 2,000. Also service providers, not only operators, but in general service providers. And you can call it a sort of organically grown structure. So we started with this, basically that's 2G and 2.5G. So we have there the SS7 protocol, which is the protocol stack used there. It's not the ISO-OSI stack, it's a different stack. We have GTP, which all your data goes over. We will go to that later on. And we have all these 2G nodes there. Then things evolved, SIG-Trump came in, that's the IP version of SS7, and so on. So then we have 3G and 4G. These are 3G. And nowadays we also have 5G stuff. And the interesting thing with mobile networks is they are expensive. They are very expensive to build up. So people don't throw away the old stuff, they just keep it. So there are areas in Finland where you only have 2G connectivity. Some operators, I think that's not the case in Finland, but in UK I know it, they see 2G as return of investment for IoT devices, because IoT subscriptions need to be very cheap, so they are supposed to use 2G because the old boxes are still out there and it's a better return of investment. So even if you have 5G, you still will see a lot of 2G stuff lying around. So in brief, so this roaming network, this private roaming network, it's sort of 38 years old, and it started very small, and it was built on trust. So, and there was no inbuilt security, no VPN, no TLS, nothing like that, no source authentication, very important, which is causing today the most of the trouble, actually. Now we have 2,000 partners. SS7 was the protocol stack used, and now it's moving on the IPX towards diameter and LTE. And 5G is on the horizon. 5G will come first for the radio part that's between your phone and the antenna. But the core network, meaning the servers behind, they come a bit later. So you might ask sort of, okay, why do we have still security problems in times of TLS and VPNs? And the answer is very simple, because those guys just don't trust each other. As said, we have parties in there which are sort of hostile towards each other. There are parties in there which are at war with each other. So there's no central authority. Imagine a Chinese authority wouldn't trust the certificate authority in US and vice versa. So just to give an example, you can also put some other countries which don't like each other very much in the moment. So their security there is a bit of touchy. So let's go back to the assumption on, is this really a closed and private network any longer? Because that's how it started, closed and private. So on the top there with the 3, you see there, in Europe there's a special thing. And the thing is that for competitive reasons, the EU Commission said that everybody needs to be able to become an operator so that the prices are nice and low. So I could set up an operator, let's say, for rental cars or for trash bins or something, go to a local operator and say, hey, I want to have access to roaming and all kinds of APIs. I want to become a virtual network operator. And the operator would need to really prove that I'm a criminal for denying me access. And the idea is to avoid that some operator just say, oh, I don't give you the access because I want to keep my business, want to protect my business. So basically everybody can set up a virtual network operator if you're technically able to do it and get access. Another way to get into this IPX network is to basically buy it from the darknet. That's there where you see the services. So you can buy the stuff from the darknet, but I'm not sure that that guy just takes your money and doesn't give you services. I didn't get it through our purchase order tool, else I would have tried, but vendor creation for darknet is a mess in a company. So on the top side, you see on the right-hand side, there is this map that's from Snowden, that's from 2007, showing which countries the NSA had access to the telco networks. That map is no longer up to date. I'm pretty sure that some of the countries have updated their infrastructure substantially. And then on the bottom, you see two cases, and these are the interesting cases where we focus on a bit today. And there are 2 cases where nodes that are telco nodes are suddenly appearing on the internet, and you can find them with Shodan. A GGSN, you don't need to know exactly what this box is doing. It's a telco node. It's not supposed to be on the internet, but still it was there, and it's sort of standing with one leg in the telco world and with one leg in the internet. So if you hack such a node, you're in the IPX. So that's why these double nodes are so interesting. So attackers can now get in, they can rent as a service. In some cases also the government and the operator are very close. Especially you have to remember that the operators, they need to get a license from the government. So if some government guys say, we want to have access to those data, well, do you want to have a license next year? It's a bit tricky. So you can hack via the internet or you can become an operator. And there are, of course, the classical ways like bribing employee or social engineering. So all of them have been seen in the wild. So nothing of it is sort of unknown. And even countries which I would say are sort of our friends and partners are somewhat, let's say, a bit shady sometimes. This is from UK. GCHQ, it's sort of the evolved MI6. They hacked Belgacom in 2013. Belgacom was a formerly state-owned Belgian operator. And they did that in 2013, and they hacked the GTP protocol. And now Belgium is asking sort of what have you been doing there, and they just don't answer. So even countries where you think, okay, they should be, Belgium and UK, they should be sort of friends and allies, no. And GTP was used here in the attack. And what's important to understand there that this didn't have consequences for them, so they can just continue doing what they were doing. GTP, maybe some work about GTP protocol. When you download, let's say, WhatsApp, Instagram, whatever you are doing with data, you use the GTP protocol. You use the GTP protocol with GPRS, UMTS, 3G, 4G, and you will also use for the user plane traffic GTP protocol in 5G. That's not yet out at product, but you will be. So GPRS tunneling protocol, it's called. It's a very important protocol as it's for your data. This is here from Shodan. We found this basically GTP scanner looking for GTP in the internet. So we were thinking sort of, okay, what are those guys searching? Most likely they are searching for these kind of nodes which are in the internet, but also in the IPX. So we were thinking, okay, maybe we can catch one of those. That was the idea of our Honeypot work, that we tried to find, really, basically catch one of those guys red-handed. So, because we got a hint, okay, they seem to be there. Some words about protocols and attack evolution, sort of just to show you how big the problem is that we are facing. But also sort of that things are not hopeless in that sense. Attacks are reality. Intelligence communities, they use it for politicians tracking and also for eavesdropping. Dark service companies, they make money with fraud. There was an attack on a banking ton in Central Europe. And also the military uses mobile network data for target localization. You might not know, but when you hear this kind of drone strike things in the news or something, the US, the Intercept has reported that 70% of the target localization data is actually coming from mobile phone networks, which is, I think, a very bad thing because it's just a cell ID. It's a sort of big round area, and the data is actually not made for this kind of purpose. So but they use it anyway. So also here these circles, that's a black service company. And let me tell you, I'm German, and if the German Bundeswehr manages to hack a phone network, there are a lot of entities trying to do that. So if those guys manage that, then there are a lot of more that also manage that. They are not the best by far. So on the bottom, you see something interesting that's from a conference in Kuala Lumpur. And Jerry Lucas is a consultant, and he has close ties to the CIA. And he has been talking about the evolution of interception and of lawful activities, as I call it. I was not allowed to go to the conference. Well, I mean, But it was interesting to see that they look at the technology evolution the same way as a network operator or as a telco company. For us, it's okay, now we have this 2G, 3G, 4G, 5G, and they look at it the same way. For them, it's also just a technology evolution, which means that even if we move with the technology, the problems will also just move to a new protocol. So it's not a big change in that thing. These are the existing attacks for the old protocol. The old protocol, SS7, is still the most commonly used protocol on the IPX, and it's very important to understand if no protection is deployed. So we have location tracking, which is, let's say, cell ID, so we know in which area of the city you are. Eavesdropping works, it's a bit more difficult. Fraud, it's very sensitive. Denial of service is actually the most easiest attack, because you just make a location update and somebody's on the moon, basically. Then credential theft, stealing your SIM card credentials, data session hijacking. And SMS interception has a sort of nasty side effect that nowadays many two-factor authentications use SMS. There was an interesting incident. There was a draft from on recommendations for security in the US, and their SMS was no longer recommended, and then they removed that sentence again because so many entities use it. What was also interesting, I made a couple of years ago showing that also with 4G and 3G you can intercept SMS. And I informed then at that point Amazon and Facebook and so on that this is possible. And from one of them I got just a feedback, I think it was Twitter. They just got the feedback, yeah, the industry knows that and we take the risk. The other didn't even bother to answer. So Google at least also used in combination the cookies, so that's somewhat better. Anyway, important to understand that not all networks are equal. There are huge differences between mobile networks. So there are networks which serve 2,000 people and they have 40, 50 employees. They don't have a security guy at all. Then there are networks which serve, let's say, China. They serve 1 billion people and they have a huge HR count. So, and also, some are just very aware of security and some don't give a damn. So you have the whole spectrum. I would say here in the Nordic countries it's quite okay. They are very diligent on security. We discuss also with them, we have workshops with them, so, and it's a sort of exchange. So as I said, it's not a homogeneous set. Some take the red pill, some take the blue pill, some don't care at all. So it's, but as an industry, we have to move forward, and that's also one reason why I'm here. I mean, when I started going to this kind of conferences, the first time our CTO got a call from a customer, what are you doing? No, it's okay. So we are moving forward. It takes a bit of time. Countermeasures. So as I said, it's not hopeless. The GSMA has some stuff. GSMA is the Association of Operators. So they know what to do for SS7, for diameter, and for GTP. GTP is, by the way, just ongoing. It's not finished yet. I just saw yesterday a document for review. And they have now started a CVE program. Their regulations, Nordic countries were the first one, actually I think triggered by Finland. And Norwegians are also very strong there. So that's might due to some neighbors that they're a bit sensitive about that, but might just be a coincidence. Then there is in the EU ENISA, which very often follows the guidance of the Nordic countries. So the Nordic countries first make their own thing and then ENISA says, oh, that's a good idea, let's do it also. The US, it's a Federal Communication Commission. They have also guidance, but US is a bit difficult in the current political climate because the climate is in the moment such that they say they don't want to mandate anything to the industry. So any recommendation there, you can put a question mark if it's really implemented or not, I don't know. So it might be that they still implement it, but it's not so pushing as in EU or Nordic countries. Also, first products came up and the first services, and that's just for information for Finland. So Ficora did that in 2016. And they're actually updating it constantly also with 4G and 5G, so they did a nice job there. So with regard to functionality, It's very similar in the 3G, 4G as the old stuff, so meaning some of the attacks also work. You might ask when in 2014, when the whole stuff blew up in our face, so why didn't we do anything directly on all of them? And why is still GTP ongoing? And the reason is very simple. We are just a few people. We are so few people. I think we are 20, 30 people. We are not more. So we are so few. And we said, okay, SS7 is burning. Let's tackle that first. Diameter was the next one. Now we tackle GTP. So it's just a resource issue, why sometimes it takes a bit longer to fix things there. It's not like the internet community where you can have a web security pen tester in every country, large amount of them. So, and these 20 to 30 people, I talk here worldwide, at least the one that work on the white side. Attacks in 3G, 4G, they are a bit more operator specific, meaning you really need to tune what you're doing to the operator. So it's not in SS7 you could have one attack tool and shoot them at all operators. In Diameter it's much more tricky to do that. So and there we found location tracking, fraud, and data interception under some very severe constraints, and denial of service. It's easy. Denial of service to subscribers usually easy. So there's stuff out there to protect. So you can monitor it, you can pen test. It sounds like normal web traffic stuff, but it's a bit more tricky since there are so few people which understand these security things in telco security for the core network. So on the radio network, it's usually well understood. The core network security is a bit, yeah. So 5G is coming. So you start bothering, okay, why should we bother about Diameter and GTP? But actually GTP is still here. So, you know that, guys? Yeah. Bobby, yeah, at least somebody recognized. I was just wondering if that's too old for here. So, but I'm happy that at least some people are the same age as me. So, old stuff, as say, in telco network survives for ages because, as said, it's also that there's even a second-hand market for telco equipment. So some of the stuff that's where here new nodes are deployed is then shipped very often to Africa. And those guys also have IPX access. So it's not that the thing vanishes. They are just used and used really till they break. So we will talk about GTP and Diameter. Diameter is the 3G, 4G control plane traffic, and GTP is used for 2.5G, 3G, and 4G data traffic and control traffic, and for 5G for the user plane traffic. So we think, okay, is everything solved? No, it's not solved. So because we want to do automation, and because in the moment the thing is such that that's the internet community. You have seen all virus total and so on. You have big databases with samples, you have signatures, you have projects where a lot of people contribute. You have all this kind of stuff. In telco, what do we have? I said I'm from a telco tribe. We have specifications, which means with regard to attacks, we have documents describing how the attacks work. But we don't have signatures, we don't have labeled data, and the PCAP files are not shared. Because the thing is that most of the traffic on the IPX network runs unencrypted. In particular, this means that the subscriber keys, the IMSI, meaning the permanent identifier and so on, are visible. So that's not necessarily something you want to share. So which makes it very tricky. And that's where our idea came up, where my colleague will say then now something. And we came up with the idea, okay, we cannot get from the operator necessarily all the data because it's so sensitive. So we thought there are scanners out there scanning the internet for GTP nodes. Let's try to catch one of them and see what they are doing. And that's now what we have been doing. And Flavia, my colleague, will now guide you through that part. So what we started basically with the first honeypot for telco networks. So.
So what can we do to catch up with the IT world? We have set up a telco honeypot on a Raspberry Pi to see what are possible attack vectors. And this is just a research honeypot. What's so special about it? Well, it has core software on it. And we also have a transparent bridge that has Wireshark installed on it and monitors the network traffic, forwarding the logs to a cloud server for further analysis. How does it look from the outside? We have three telco ports that are open and visible in the internet, and that is port 36412, which is S1 control plane, and then two UDP ports, 2123 and 2152, that are GTP ports. Okay, so what exactly is this core network? It has four main components. Well, first of all, it's latest version of 3GPP's specification for LTE networks or 4G networks. And there are these four main components: the mobile management entity, or MME, to which the antennas or eNode Bs connect to. On that one, we have port 36412 open. Then we have the home subscriber server, or HSS, which actually contains the subscriber data. And that's where the crown jewels are. So in the honeypot, we added some realistically looking, but still fake data. And we are hoping to see some attempts to either modify or fetch that data. And there is also two gateways. The serving gateway, or SGW, that connects either to an MME or to an antenna, the eNode B. And that one has the UDP port 2152 open. Its role is to deal with user plane for transporting IP traffic between the EU tram part, when that's composed of antennas and user equipment, mobile phones or other devices, and also routes incoming and outgoing packets. And finally, we have the packet data network gateway, which transfers, or actually is the connection point between the SGW and other external networks, and that can be accessed on port 2123. Let's zoom out a little bit to see how do phones actually communicate with each other in two networks. These networks can be either two different networks in the same country, or either while you're roaming. So we have the user equipment, here depicted as mobile devices, which connect to antennas. And, the antennas connect to the MMEs, then we have the HSS database and the diameter edge agents, or DEAs, that communicate to each other over the infrastructure of IPX providers. So what we have seen in the honeypot until now. So the honeypot has been running for about 4 months already. Well, we have seen just common, or mostly common, IP attacks, the telnet, port 23, SMB attempts, Microsoft SQL, and then session initiation protocol and common HTTP connections. Also a bit more rare attempts like this one on port 53,413, on port, yeah, I mentioned that. And this is an attempt to access a backdoor in a NetEase router. It didn't work, of course, because that port is not open for us. Quite a lot of session initiation protocol attempts, on port 5060. And finally, something related to GTP. This was just an echo request on port 2152. And these telco attempts have come mainly from China, Russia, US, Ukraine, and just a few from Belgium. What are we gonna do next, or what we are expecting from this honeypot is to see some more advanced attempts on the telco ports. Okay.
Okay. So, thanks. Basically, I found it interesting on the previous slide that Belgium was in there, but not UK, which is sort of, especially in combination with this other incident where they didn't comment on the GTP attack on Belgacom, which is nowadays Proximus and a roaming partner of some of the Finnish operators. So I'm wondering actually about that. But the thing is, when you see these IP addresses and so on, you don't know exactly where the stuff is coming from. So even if you put there these, I basically mapped there, in real life I saw sometimes a lot of attacks coming from Africa, where I'm pretty sure that they were not originating in Africa. So, and besides, as we can see with the UK example, so even if they are caught red-handed, it doesn't mean anything. So nothing basically happens after that. So the idea is basically to try to learn and to stop whatever kind of nasty stuff is arriving. What we want to do next is we want to evolve this core network honeypot. So in the moment it has sort of basic functionality, sort of we answer, we make it look a bit like a real core network node. But we need to really support sort of a lot of features in GTP, and also for diameter, not just sort of very simple stuff, but also the more advanced stuff. So we hopefully get more interesting attacks, and we need to try also to be really looking convincing real. So in the moment it's sort of very rough. As said, it's the first core network honeypot, hasn't been done before. And then comes something, because in real life there's a lot of there are huge amounts of data we talk about, and it's very difficult to pick in the pcap files the attacks and find them. So we need some sort of data crunching, and that's sort of pretty tricky because you have strings, basically, and you need to convert them into something sensible so that you can put clustering algorithms and so on it. I love math. So, but for that we need to transfer the data into integers, floating points, whatever, but we also need to maintain structure. So if an attack occurs every Monday at 7 o'clock, we need to be able to see that in our clustering algorithms. So that's the next step we are going there. And it's a bit of hard crunching there, but well, we can do it. So what about 5G? I mean, everybody's talking about 5G, you see it in advertisements, and 5G is not out there for core networks, it's only out there for radio networks, but we still think about sort of what might to expect if 5G. So let's have a look at the specifications. The air interface for you from here, from your phone to the antenna, it's really good, the security in 5G, also against false base station attacks. There's also unified security, so it doesn't matter if you use operator wireless LAN or the cellular access doesn't matter. And they also first have an edge proxy, a sort of firewall in the architecture. Imagine that. So it's moving forward, but there's still a lot of work to do. And you don't need to know the abbreviations, don't worry. But there it gets interesting for you IT guys. And 5G introduces the concept of service-based architecture. And you know what that is? REST API, HTTP. Sounds familiar? So we are going to use HTTP and REST API calls, so meaning that you see these red lines there. The nodes that are attached to it, they are for charging, they are for location management, so tracking where you are. They are for session management and access management and so on. Those guys can talk to each other, then also can talk to each other if they are in a visited, left-hand side is the visited network, on the right-hand side you see the home network, so they can also talk to each other across roaming networks. So, or for example, when you make a call to another operator. Which means that you need to have a firewall there which understands the content, and you need to have authorization in place. So, and on the lower plane you see something which also crosses this magical line, this magical dotted line. That's the N9 interfaces. That's where all your data is going. That's when you are abroad and download a web page. That's where all the data is. It's GTPU traffic and it's unencrypted. So use HTTPS. So, and this GTPU traffic, GTP version 1 protocol is used there. And that's still, this 205G protocol basically is being used there. So you know these get, post, put, patch, and delete functions. What does that mean in telco terms? I mean, you all know how that works, but in telco terms, which means, for example, does it make sense if this for this subscriber, the other operator requests location or cryptographic keys? It might make sense. For example, Elisa is mainly in Finland, but they're also in Estonia. So they might use one server from both countries. It's cheaper, it makes sense. Economically, it makes sense. So there might be a good reason to do that. But on the other hand, you probably don't want to request, let's say, somewhere from the east. So what are you allowed to, new elements are you allowed to create? Let's say, are you allowed to create charging data records, so where your money is going? Gets interesting. New users, new fake users, denial of service attacks. Do you allow a roaming partner, let's say, to change a prepaid subscriber to postpaid? I don't know if you're completely clear what that means. If I change a prepaid to a postpaid, that means that basically this person would have 1 month of free data or whatever services. In Finland, where many subscriptions are paid by companies, that might not be such a big deal, but in many countries it is. And are you allowing other operators to delete subscribers? This is basically from specifications. So what this means that if the network is hacked, you have a node which talks to your main database where really all your subscribers are in, everybody. And are you allowing this guy to do something, whatever something is? And so you have to check that this guy is allowed to do that. For web developers, this is sort of obvious. But on the other hand, we see regularly when databases are breached that it's not always exactly working. And we have a lot of interesting data there. We have subscription data, meaning opportunity for location tracking and fraud, and for data interception. So there are risks there if things are not done properly. That's always a sort of important lesson to learn. REST API. There are a lot of potential risks, sort of remote code execution and so on, data stealing, denial of service attacks, fraud and data. The main point about this is to understand SS7 from 81. Basically the first awareness that something might be could be misused if somebody breaks into this private network. The first hints were there 94, 97. And then basically till it really sort of became public knowledge, it was 2014. So there were roughly, let's say, 15 to 20 years before things sort of blew up. With Diameter, we had sort of 2 to 3 years. And the thing is that with REST, when we use REST API in 5G, we have a day, 2, sort of around that. So it's a big change in industry, sort of the speed we need to react. So we need processes, we need red teams, we need people that react to it, and also sort of processes in place, even on weekends and things like that. So So also this is basically a to-do list for 5G. And it falls on operators, it falls on network manufacturers. Actually, as a user, you can do very little about it. So you learn from the past. So we changed testing stuff. We changed rollout procedures and things like that. And for operators, the good ones came up with incident response plans. They discuss it together with the regulators. They do firewalls inside the networks. Remember, in the beginning, they didn't have any firewalls at all. Now they have even inside the networks firewalls, patching plans, and keep up to date. We still sometimes see from operators, we get these requests for boxes, and they just say, give us a secure box. And will you patch the bugs we had with SS7? And we try to explain them, this is something continuous. You are now in the sort of internet age. We need to continuously, where vulnerabilities are, we need to patch them. So it's not that we just give you a box and it will stay safe for 20 years. It doesn't work any longer like this. And there's a big education gap also. And as I pointed out, authorization and authentication, it's really who is doing what, and this is something that operators need to do because they have a roaming contract with other partners, and that defines what they are allowed to do. Do you allow them to change things or not? And clean IT housekeeping, I don't need to say anything in this room about here, and pen testing. So with technology, we cannot switch it off. We are all addicted to it. If I see my kids, if I take away their phone, it's probably life-threatening. 5G is coming, so we just move forward and have to pay attention to security and try to evolve with it. And the EU is actually giving money for this kind of research, which I think is also a good idea. And now to the Q&A part. So, thanks a lot. So, what's questions? Just shoot. No questions? Nobody wondering about if he's tracked?
There is one.
I think there's a mic coming. Maybe it's easier. Thanks.
All right. Did you publish your code? If we want to do our own honeypots, can we do it? How do we start?
Yeah.
Yes, you can do your own honeypot. The thing is to have the GTP ports open and the diameter ports. And for diameter exists actually some, you can find on GitHub some S6A interfaces and so on, which then would respond in the right way. So you can do that yourself, yes. So you need to wait a bit till Shodan and other search engines find it, basically, but then you get data, yes. So most are just echo requests, but there are also some SIP attacks and so on. You can do it. Everybody can set up this kind of honeypot, and these are basically, I would assume, mostly governmental attacks. So I invite you to do that. So if you do that, that's great. So if we are not the only ones sort of doing this kind of weird thing. Anything else? No further questions? Okay, then let's hope that the Finnish operators sort of are progressing with 5G as they did for 4G and 3G. And thanks a lot for your time. Thanks.
Thank you.